Hi everyone, this is video number 21. Okay, so for this series I'm going to talk on line integral. We begin with some introduction. What is line integral? Line integral, basically we integrate over a curve. Okay, we integrate over a curve C. Yeah? For example, if you have like that, this is from A, from B, this is our curve C. Okay, we name that as a C curve C. Then we integrate, and there is some function here. Integrate from A to B, f of t dt, for example. So we want to integrate like that. Okay, I will give you a full definition. How do we define the line integral? Okay, now as a starting point, let's consider if you have an object. If you have an object, all right, where we pull this object with a constant force phi, constant force F, from a point A to a point B. So what do we have? We're going to have force F pull with constant force. I can say a constant force F, constant force F, pull the object from A to B. So that yields the what we call work, where work we define W as F dot R, where R is a vector from A to B. So if you look at here, this is just a constant. This is the a variable. Now if you differentiate this, that contribute nothing, because this is a constant variable, a constant function. Now we consider those objects. Consider from a point, let's say A at t equal to A, to some point t equal to B. All right. So this is some from position vector. Let's say RT. Okay. So we assume that a particle is moved along a smooth curve C, along a smooth curve C, where C is described as a position vector RT with component xt, yt, zt. All right, where nt between A and B by a constant force by a constant force F PQR. Then work done by F along C. So basically, if we integrate from A to B, W prime T dt, that basically we integrate W, we got W, integrate W prime, we got W, and we evaluate at point B and A. So what we have is basically work at B minus work at A. Alright, so this is equal to, if you integrate this, differentiate those W prime, since W F is a constant, yes, F is a constant. So what we have, this is integrate from A to B. We have F of that R of T dot R prime T dt. Okay, so we define this as a line integral. Okay, we define that as a line integral. And in some book, you can find a little bit different definition, but still give the same meaning. Yeah, in some book, set W as a, we integrate along C F dot T ds, and we know that T is a R prime over R prime. Okay, so then we can change those things. We have C F dot R prime over R prime ds, and what do you know? ds is the magnitude of R prime dt. So we have here that give you F dot, this one is R prime over magnitude of R prime, that one is R prime dt. Okay, if you cancel out those things, that give you F dot R prime dt. Okay, so that's we define as a line integral. If you look at the previous definition, we also have this is in previous page, we also have F R prime dt. Okay, so let us go to the formal definition. Okay, let F be a continuous vector field. Let F be a continuous vector field. VF is a vector field on a smooth curve C, where our C is described as the position vector R given as xt, yt and zt. This is the component of R, where t in AB. All right, then work done by F along C done by F along C is defined as we integrate from A to B F R of T dot dr. This is equal to integrate A to B F RT dot R prime T dt. Of course, you can write this dr as a dr. Dr is dr dt dt. So that gives you R prime. So that's what we have there. Okay. Now I'll give you an example. Right. Before that, let me stress again the definition. So what we want to find is that, or if we have a curve, smooth curve C from a point T equal to A to a point T equal to B. Basically, if you have an object here, and you pull this object with a constant force towards from that point, let's say point A to point B. So if you pull this along that smooth curve C, so what we have is the work. Right? So we define those work by the previous page. We know that the work is given or defined as that. Alright? So how to evaluate is given by those definition. So the process now is how to find the work, how to find the work when we pull the object from a point A to point B using the constant force. So that's basically what we are looking for. Okay, so let's say example. I just give you simple example. For more complicated example, do it yourself. Okay, say example. Let's say we have F given as xy as a x square y squared. Okay, this is component for I, this is component for j. You know this definition. This you know this notation. And C is given as t squared t, and t 0 1. Okay, now we want to find or we need to evaluate F dot dr. Okay, in other words, I can write this along C F dot dr. It's just the same meaning. Okay, or in words, we can say that evaluate the line integral of F along C. So all these have the same meaning. Yeah. So how to do this? Okay, see carefully. How do we do this? So our R, by definition we have R, T is given as t squared t. This is from the question. This is component for x, this is component for y. So I can write here our x, remember that in general, our r is defined as xt, yt, zt for 3 dimension, but now we have only 2 dimensions, so we don't have z. So which means x is equal to t squared, y equal to t. So we have x equal to t squared and y equal to t. Okay. Now for f, what is our f? This is our f. Okay. So we have, but we have our f is those things x squared y, this is component for I, plus y component for j. Okay, if you substitute this x and y into that, so what we have now, our f become f of rt. Okay, so because we substitute x and y with parameter t, so we have x is t squared, so x squared, so we have t squared and y is t, this is component for I, plus y is t, this is component for j. So what we have here is a t5i plus tj. Okay, and look at this formula. We have f, we need f, we already have f in terms of t. Now dr, what is dr? If r is given as this, right, if r is given as that, r by definition is that, which means dr, we differentiate r, means we differentiate those things. Alright, so which means this is dr is a dx dy. Okay, so basically what we have for dx, what we have dx, just use that, dx is 2t dt, and dy is, where is dy? Dy is dt. Okay, so integrate t from 0 to 1, this is from the question, f dot dr, so we have integrate t from 0 to 1, our f is, we already found f here, is t fifth t and dot dr. Our dr is given dx dt, so dx is this, dy is this, so we have 2t 1 dt. Okay, so dx is 2t, dt we bring it out, dy is dt, we take out dt, what left is only 1, so we have 1 there, component for y, so dt. Then the rest I think you can do it, should have no problem here. Remember that we have dot product here, do not confuse, this is dot product. So we have this integrate from t 0 to 1, this is 2t6 plus t, this is t squared y t, right? Here y is t y squared here, y squared, so where is it? Here, this is y squared, that's a mistake, y is t, so we have t squared here, there should be, this is t squared, alright, so this is t squared, so it should be t squared dt. Okay, then you can solve this. That give you 13/21. Okay. Just one thing here, do not make a silly mistake here. Okay, dot product give you a scalar, no more vector, no more ij here, so don't do that silly mistake. Now, yeah, for this one, let me end up with a some exercise. Please do. Okay, find the work done by F, find the work done by F, where F is given as xy, yz, and 1. Along C, where C RT given as T squared and T cubed. From P minus 2, 4 minus 8 to Q 1, 1, 1. Okay, so answer is 1179 over 28. Can you read that? Find the work done by F given by that, along C given by that, from P that to Q that. Okay, and let's say this is A or one B. B we change C, similar as above, similar as in A, but our C is a straight line connecting P and Q, connecting P and Q. So in this example, so you may consider in this case C sort of a curve from P to Q. Let's say you have a point P here and a point Q here, probably like that. Okay, and those are probably you have something like this, and then that. So this is the first case. This is the path that we use. Whereas for the second case B here, we just connect straight line. I think you can find the equation, the straight of those straight lines. It should be no problem for you. Okay, so you try that exercise. If you have any problem, please well, you can just WhatsApp me, then I will discuss in the next video. Yeah, thank you.